Today's lesson is about differentiability and a little repeat on position, velocity, and acceleration. This is the first worksheet that we're looking at. It gives you a graph of position versus time, which we haven't really looked at. And they're asking you when Jason's velocity is approximately 0. Now velocity, remember, is in this case is going to be meters per second. That's what velocity is. And if it's 0, it means you have a horizontal line. So it looks like, my guess would be at t equals 3 and at t equals 7.5. That's just an eyeball, okay? Approximate Jason's velocity at t equals 2. So here it is. I'm going to draw a tangent line, and I'm going to pick 2 points and check the slope. It sort of looks like it goes up 2 and over 1. Now let's see, up 2 and over 3. That's it. So I'm going to call it 2 over 3. That's his velocity. It's the slope of the line. Okay? This is estimating velocity. We did this. We had a whole worksheet on it. Tables, they want to know the velocity at 3. I did it 2 different ways. I used 2 and 3. I used 3 and 4. I used 4 and 2. Did the math. They're all pretty darn close to 2, so I wrote the answer as 2 miles per minute. Okay, the last one on here is a projectile is shot upward from the surface of the Earth with an initial velocity of 120 meters per second. The position equation is negative 4.9 t squared plus 120 t. Those of you taking physics should know what negative 4.9 is. Okay. It says, what is the projectile's velocity at any time t? Well, velocity is the derivative of position. And so 2 times 4.9 plus 120. It says, what's the projectile's velocity after 5 seconds? You just plug 5 into the equation and do the math, and you get 71. The projectile's acceleration is the second derivative of position, or the first derivative of velocity, and you get negative 9.8 meters per second squared. That's gravity. Okay, our next lesson today is notes on differentiability, and we want to talk about points where the function's differentiable and how to check whether it is. Okay, the first one, we know this is an absolute value graph. That plus 4 shifts it over here to negative 4. Oh, and it goes up 3. Sorry, it goes up here. So they want to know, is it differentiable at negative 4? And the answer is no. Is your slope from the left does not equal the slope from the right. Okay? All right, this function is a piecewise function. And if it's differentiable, it has to be continuous. So the first thing you do is you plug in 1, and you get negative 2 plus 4 equals 1 plus 1. And you get 2 equals 2. So therefore it's continuous. Then you have to check the derivative. Okay, check derivative. The derivative of the first function is negative 4x. And we're checking it next to 2x, and when I plug in 1, I get negative 4 equals 2, and it doesn't. Since the left does not equal the right, it's not differentiable at 1. Okay, first check for continuity, then check for if the derivatives are the same. This one wants to know if it's differentiable at negative 2. Well, if you plug negative 2 into the function, you get the 5th root of 0, and that's 0, and that's okay. Negative 2's in the domain, okay? And it's defined. F of 2 is defined. Now, so we know it's continuous. Now, take the derivative. So the derivative is 1/5 x plus 2 to the negative 4/5, which is 1 over 5 times the 5th root of x plus 2 to the 4th. What happens when you take f prime of negative 2? You end up with 1 over 0. That does not exist. Okay, so it's not differentiable. Even though the function's defined there, it's not differentiable. It's continuous, but not differentiable. Okay, let's try the next one. You plug in -1. -1 squared is 1, so this is 2 plus 1 equals 2 minus 2. And you get 3 equals 0, so it's not continuous, so you give up. Because if it's not continuous, it can't be differentiable. Okay, plug in 1 here. You get 2 plus 3 equals 1 plus 4. 5 equals 5. Continuous. If I take the derivatives, I have 2 equals 2x. And you plug in 1, you get 2 equals 2. It's differentiable. Left equals right. That's the slope. Okay? What about this one? If you plug in -8, does it work? You want the cube root of -8 squared. So that's -2 squared equals 4. So yes, f of -8 is defined. Okay, now take the derivative. F prime 2/3 x. So the -1/3 equals 2 over 3 times the cube root of x. And you plug in -8 and you get 2 times 3 to the times -2 is 2 over -6, -1/3. Yep, it's differentiable. Got an answer. All right. These type of problems I'm sure you will see again, so pay attention. You want to find a and b to make f of x differentiable. So the first thing, it must be continuous. So when you plug in 1, they have to equal each other. No sharp turns. So we know about if they run into each other, there's one going this way and one going that way, one going up and it turns. If there's a sharp point there, it's not differentiable. And no vertical tangents. That's your cube root function. Okay? So let's look at this first one. If I plug in 1, you get a plus b equals b minus 1. Subtract b from both sides, and you get a equals -1. If it's going to be differentiable, the derivatives have to be equal. The derivative of this is a. The derivative of this is 2bx. We know a is -1, and x is 1. So b is equal to -1/2. Those are the values that are going to make it continuous and differentiable. The derivatives are equal, and the functions are equal. What about this one? Plug in pi, you get pi squared, a pi squared plus the sine of pi equals 2 pi minus b. The sine of pi is 0, so you get a pi squared equals 2 pi minus b. Well, I don't know what else to do, so I'm going to take my derivative first. Your derivative here is 2ax plus the cosine of x equals 2. You plug in pi, cosine of pi. Cosine of pi is -1. Whoops. -1. So 2 pi, a equals 3. So a equals 3 over 2 pi. And if you plug that back in over here, well, that's interesting. I did my math wrong the first time. All right, so now I have 3 pi squared over 2 pi equals 2 pi minus b. This, that crosses out, so I have 3/2 pi minus 2 pi equals -b. So that's 4/2. That's -pi over 2 equals -b. So b is pi over 2. What did we say a was equal to? 3 over 2 pi. We got one more example of that. It was on a worksheet we did out right when we talked about differentiability. Down at the bottom were 4 problems we said we'd do later. They want to determine if these functions are differentiable at 1. Plug in 1. 1 squared is 1 minus 1 plus 2. Plug 1 into this one, you get 2 plus 1, so you get 2 equals 3. That's not true, so it's not continuous. Therefore, it's not differentiable. What about this one? You plug in that, you get 3 minus 3 equals 1 minus 1. That's true. 0 equals 0, so it's continuous. Not enough, though. You have to check if the derivatives are the same. So the derivative here is negative 3 equals 1 minus 3x squared. And you plug in 1. So negative 3 equals negative 2. Nope. So it's not differentiable. Say once it's not continuous, you can quit. All right? All right, get rid of my scratch work here. Same thing, differentiable at 2. You plug in 2, you get 4 plus 1 equals 8 minus 3. 5 equals 5. Yes. Derivatives, 2x equals 4. You plug in 2 and you get 4 equals 4. Yes, so it's differentiable. Use the whole words, I'm being lazy. Okay, plug in 2, you get 1 plus 1 equals square root of 4. So 2 equals 2. Bingo, that's nice. Derivative here is 1/2. The derivative here is 1/2. Remember, this is the chain rule. 2x to the negative 1/2 times 2. So you get 1/2 equals 1 over the square root of 2x. And you plug in 2. And that's true. So yes, it is. Don't forget the chain rule right here. Okay? And that's all there is to today's lesson. A little refresher of things we've learned before. Now go practice.